Today's lesson, section 11.1a, we're talking about parabolas. A parabola is the set of points in the plane that are equidistant from a fixed point F, which is called the focus, and a fixed line L, which is called the directrix. The vertex is the point on the parabola, which is halfway between the focus and the directrix. The axis of symmetry is the line that runs through the vertex and focus, but is also perpendicular to the directrix. Now this next word, you're going to have to get your chuckles out now, because I'm not probably going to use this word again, but this is the formal word for this. So the latus rectum is the line segment that runs through the focus that is parallel with the directrix and has endpoints on the parabola. Okay? We usually don't use that word. We'll call it the focal width or the focal diameter, because we're usually talking about the length of our latus rectum. Okay, so get your giggles out now and let's move forward. Okay, so a parabola is usually aligned with the vertical axis or the horizontal axis, which is going to be talking about your axis of symmetry. Okay, so when it's vertically aligned, your axis of symmetry is an x equals 0 in this case. Usually, if we had it moved, it will be h, but right now it will be 0. Okay, so it's vertical, so that means it's either going to open up or it's going to open down. For when it's horizontal, the axis of symmetry is going to be a y equals line. So that means that it's either going to open to the right and open to the left. So for this, you're going to have equations that look like x squared equals 4py and y squared equals 4px. Now usually, if you remember from advanced algebra, and maybe that's changed from previous use, but usually when it's taught in Algebra 1 and Algebra 2, the equations for a parabola are like y equals a times x minus h squared plus k, because it's easier to write because that's vertex form. But here we put it in these forms because it kind of matches the stuff that we're talking about with conic sections a little bit better. So yeah, so the x squared will be the one that's by itself, and then you'll set it equal to 4p times the other variable, which is y, and then vice versa for the other one. So now for these parabolas and for the ellipses and hyperbolas that we talk about, they're going to be centered or have a vertex of 0, 0. Okay? So we're not going to shift them at all. They're going to be just centered around the origin. So don't worry about moving it or anything. We'll deal with that in section 4. So for the vertical axis, your focus is 0, p. For horizontal, it's p, 0. Directrix is y equals negative p for our vertical axis, and directrix for the horizontal axis is x equals negative p. Now notice, if you remember, if the y is by like just to the first power, then your focus and your directrix values for the focus, like for that p value, that's a very important value, is going to be in the y position. So if it's in the x's to the first power, then your p's will be in the x position. Okay, so nice, little helpful hint there. So also, to help you understand if it's open up, down, left, right, so if p is positive and you're on the vertical axis, it'll open up. If it's negative, it'll open down. For the horizontal axis, if it's positive, then it'll open to the right. If it's negative, it'll open to the left, and you'll get pictures like this. Remember that your foci, or your focus, is going to be inside the bowl for all your parabolas when we graph them, and the directrix is going to be a line behind it. So just remember that your parabola will never cross the directrix because it's going in the opposite, like the parabola is going in the opposite direction of the directrix. Okay? and then you have your vertex centered at 0, 0 in these problems. Okay? Now, also another thing that's not listed here, we talked about it earlier, what is focal width equal to? Okay? It's equal to the absolute value of 4p for both. So, whatever that 4p is equal to up there, you just take the absolute value of it, and then you get your focal width. So that's another piece of important information. Now notice, for all your stuff, p is involved. So anytime we're looking for stuff, we need to figure out what p is first, and then we can figure out the rest from there. Okay, so example 1 says find the focus, directrix, and focal diameter, then graph each parabola. Okay, so here you have for letter A 2x plus y squared equals 0. So to move forward from here, you need to have it in the proper position, so we need to get y squared by itself. So I need to subtract both sides by 2x. So it gets me y squared equals negative 2x. So then what I usually do is I take 4p and I set it equal to the value that's multiplied to the variable that's to the first power, so that I can find what p is. So here I just divide by 4. It gives me 1/2. Now because y squared is the one that's squared, that means that, and also because x is to the first power, then all my stuff is attached to the x part. So your focus will be the same as p comma 0, so negative 1/2 comma 0. Your directrix is going to be an x equals line, which is x equals negative p, so it's the opposite of what your p value is, which would be 1/2. Okay? And then also I want to find my focal diameter. Remember, that's the same thing as focal width. So the absolute value of p, so if you plug in 4 times negative 1/2, that gets you negative 2, and the absolute value of that is 2. Okay, so now that you have all the pieces of information, now you can graph. Let's do there. Okay. So you know that your vertex is 0, 0. Then we graph our focus. Let's make this a little bit more spread out, so it's easier to see. So then my focus would be right here. Okay? And then my directrix would be back here. And then from there, I want you to be able to get a decent picture. Now, because you're given the focal diameter, here's a trick that you don't have to plug any values in to find any more points, but you can create new points. So because your focal diameter is 2, okay, that means that from one side to the parabola to the next side is 2, but it's a parabola, so it has an axis of symmetry that splits it in half. So since your focus is on that midpoint line, then it's going to be 1 on one side of the focus and 1 on the other side. So you go up 1 in this case, and down 1 from your focus in line with your directrix. That creates your 2 points, so that you can graph it with some type of dimension without having to plug anything in to find new points. Okay? So that's what I kind of would hope for when you're graphing these points and making your parabolas. Okay? Let's go back up. So I have y equals 4/9 x squared. I want to get the x squared by itself. So I need to multiply both sides by 9/4. So that gets me x squared equals 9/4 times y. So then here, I want to set this equal to 4p. Now I'm going to divide both sides by 4, but here, because it's 9/4, I can also multiply both sides by the reciprocal, which is 1/4. So P should equal 9/16. Okay? So now using that, my focus, now because your Y is in the first power position, then that means all your stuff is going to be aligned with P, or with Y. So it'll be 0, 9/16. Your directrix will be the opposite, where it's Y equals the opposite of P, which is negative 9/16. And then your focal diameter, so 4, the absolute value for P, so 4 times 9/16. So that gets you the absolute value of 9/4, which is just 9/4. Now I know there's a simpler way to do the focal diameter. You just take the value that you had here or here, and you just take the absolute value of it. And I understand that. You can do that. I just want to do it formally so you understand where it comes from. Okay? So now I want to be able to graph. Okay? So let's do the same thing and make it a little bit larger. Okay, so now you got your vertex in 0, 0. Your focus is going to be 9/16, so that's a little bit more than half. So it'll be right about there. 0, and then the same thing for your directrix. And we'll label that as well. Okay, and then here I want to use my focal diameter to help me get a decent picture. So because it's 9/4, half of that would be 9/8. So that's a little bit more than 1. So if I go over and plot a point, make it a little bit bigger right there and right there, then I get a decent picture. It doesn't have to be super exact, but I want to get a decent scale of my picture so I have the right width. Okay? Alright, and there's our lesson. Have fun.